Question 1. What is the primary objective of natural language understanding (NLU) testing for a bot? Option A. To assess the bot's visual design and user interface elements. Option B. To verify the bot's ability to correctly identify user intents and extract relevant entities from utterances. Option C. To measure the bot's response time under heavy load conditions. Option D. To ensure the bot's integration with external databases is secure. The correct answer is to verify the bot's ability to correctly identify user intents and extract relevant entities from utterances. Here's the explanation. NLU testing specifically focuses on validating the bot's core ability to understand what a user means, intent, and to pull out key pieces of information, entities, from their natural language input. Question 2. When preparing test data for bot testing, what type of utterances are crucial to include beyond just happy path scenarios? Option A. Only the most common and straightforward user inputs. Option B. A comprehensive set of edge cases, negative scenarios, synonyms, and multilingual inputs. Option C. Only utterances that lead to successful task completion. Option D. Utterances exclusively generated by the bot itself for self-validation. The correct answer is a comprehensive set of edge cases, negative scenarios, synonyms, and multilingual inputs. Here's the explanation. Robust bot testing requires a diverse data set that covers not just ideal interactions, happy paths, but also challenging inputs like edge cases, out-of-scope requests, negative scenarios, varied phrasing, synonyms, and different languages to ensure comprehensive NLU and dialogue management. Question 3. What is a key differentiating challenge when testing conversational AI bots compared to traditional software applications? Option A. Bots require significantly more performance testing than traditional applications. Option B. Bots are exclusively tested manually, unlike traditional software. Option C. Bots must contend with the variability and ambiguity of natural language, context management, and non-deterministic responses. Option D. Bots do not require security testing, whereas traditional applications do. The correct answer is bots must contend with the variability and ambiguity of natural language, context management, and non-deterministic responses. Here's the explanation. The inherent variability of natural language, the need for context management over multi-turn conversations, and potentially non-deterministic responses make bot testing uniquely challenging compared to traditional software with more fixed graphical interfaces and deterministic inputs. Question 4. What is the defining characteristic of generative AI models that distinguishes them from traditional discriminative AI models? Option A. Their ability to classify or predict based on existing data. Option B. Their focus on analyzing historical data for business insights. Option C. Their capability to produce new, original content. Option D. Their exclusive use of rule-based expert systems. The correct answer is their capability to produce new, original content. Here's the explanation. The overview states, unlike traditional discriminative AI models that primarily classify, predict, or analyze existing data, generative models create novel outputs. This is the core distinction. Question 5. Which of the following is not listed as a common neural network architecture used in modern generative AI models? Option A. Transformers. Option B. Generative Adversarial Networks, GANs. Option C. Variational Autoencoders, VAEs. Option D. Decision trees. The correct answer is decision trees. Here's the explanation. The key features components, section lists, transformers, generative adversarial networks, GANs, and variational autoencoders, VAEs, as neural network architectures for generative models. Decision trees are a traditional machine learning algorithm not a deep neural network architecture for generative AI. Question 6. In the training phase of a generative adversarial network, GN, what are the two competing neural networks and their primary roles? Option A, encoder for feature extraction and decoder for reconstruction. Option B, generator creates data and discriminator distinguishes real from fake. Option C, input layer receives data and output layer produces prediction. Option D, attention mechanism weighs importance and feed-forward network processes features. The correct answer is generator creates data and discriminator distinguishes real from fake. Here's the explanation. The How It Works section explains that a GAN involves two competing neural networks, a generator that tries to create realistic data, and a discriminator that tries to distinguish between real and generated data. Question 7. What is the primary advantage of using Azure OpenAI Service over the public OpenAI API for enterprise applications? Option A, access to a wider range of foundational models, e.g. GPT-5. Option B, lower token processing costs for all models. Option C, enterprise-grade security, data privacy, and responsible AI features. Option D, unlimited access to models without any quotas or rate limits. The correct answer is enterprise-grade security, data privacy, and responsible AI features. Here's the explanation. The Azure OpenAI service integrates OpenAI's models with Azure's robust security, AAD, VNet, private endpoints, compliance, data privacy, customer data not used for training foundational models, and responsible AI features, content moderation, abuse monitoring. This is a significant differentiator for enterprise use cases compared to the public OpenAI API, which lacks these integrated features. Question 8. A company is building an application that uses Azure OpenAI Service. They are concerned about preventing the generation of harmful or inappropriate content. Which feature is built into Azure OpenAI Service to address this concern by screening both prompts and completions? Option A, fine-tuning capabilities. Option B, private network connectivity. Option C, content moderation filters. Option D, Azure Active Directory (AAD) integration. The correct answer is content moderation filters. Here's the explanation. Azure OpenAI Service includes built-in content moderation filters that screen both prompts, input, and completions, output, for harmful content, abuse monitoring, and human review processes. This is a core part of its responsible AI features designed to prevent misuse and ensure safe content generation. Fine-tuning, private network connectivity, and AAD integration serve other purposes. Question 9. When an application wants to use a GPT-4 model via Azure OpenAI Service, what is the correct way to interact with it? Option A, directly call the global GPT-4 endpoint provided by OpenAI. Option B, provision an Azure OpenAI resource, deploy a GPT-4 model within it, and make API calls to that specific deployment endpoint. Option C, use Azure Machine Learning to host the GPT-4 model directly. Option D, download the GPT-4 model to a local server and run it there. The correct answer is, quote, provision an Azure OpenAI resource, deploy a GPT-4 model within it, and make API calls to that specific deployment endpoint. Here's the explanation. To use Azure OpenAI Service, an Azure subscriber first provisions an Azure OpenAI resource. Within this resource, they then deploy specific OpenAI models, e.g. GPT-4, as named deployments. Each deployment creates a unique, dedicated endpoint, and applications make API calls to this specific deployment endpoint. Options A, C, and D describe incorrect or alternative methods not aligned with Azure OpenAI Services operational model. Thanks for watching. Please subscribe to my channel.